Hello, everybody, and welcome. Kuju, you got me right as I was starting. Taman, how's it going? Kuju, thank you for the raid. I appreciate that. Let me give you a shout out real quick. So, for those of you who aren't following Kuju, he is making a pretty awesome looking game. It's coming along really nicely, in my opinion, called Fat Goblins, and he's doing it in Jai. So if you're not following him, definitely go do it. Yeah, thank you so much for the raid. We're actually just kicking off the stream here, so welcome raiders. What we're doing on the channel is actually let me pull it up real quick, and I'll give the quick and dirty sort of intro here. So what we're making is called the Kohi game engine, and what it is it's an engine that we're building from scratch using C and then using Vulkan as our initial rendering backend. I say initial because it's the first of a few that we're going to have. We're going to support Direct 3D, and we're also going to support Metal natively as well. It is a cross-platform engine, so it does run on Windows, Linux, and Mac OS. And it is free and open source. So it is available on GitHub. It is Apache 2.0 license, which means that you can use it either personally or commercially is the word I'm looking for. And the only thing that I ask is that you just say you use it if you use it. There will never be any sort of licensing fees or royalties of any kind. It'll always be open source and free. The reason I'm doing this is because it is sort of the resource that I wish that I had when I was learning how to do this stuff. And so we're basically doing this as sort of an educational exercise. And so it started off as a YouTube tutorial series, and it kind of changed formats a couple of times as we went through it to see what works and what doesn't work. Ultimately, we landed on the live stream format. So that's what we're currently building. And there's all kinds of links here. I dropped a link to the main site, which is cohiengine.com. We also have a Discord server with about 1,000 people on it. It's a little over that now. YouTube, Twitch links, all that good stuff. So that is what we're building. And we're in the middle of a decent sized refactor right now, so I actually can't run it and show it to you at the moment. But we have a basic PBR pipeline running. These screenshots are a little bit dated. They'll be updated once we actually complete the refactor. But we have a basic PBR pipeline with cascading shadow maps. We do have we recently added a water plane in there with reflections and all that shiny stuff. We have UTF font rendering working, bitmap fonts, system fonts. We have our own UI system that we started building from scratch. And so all of that is, it's in progress, right? It's still kind of early days, but that's basically where we're at. So it's kind of a big project, and we're actually looking at starting to develop the first game for it. I'm hoping by the end of the year we can actually kick that project off. It might be a little bit longer than that, but I'm really trying to actually at least have it kick off then. I can actually pull up a quick... I'll pull up the sort of game design document that we started drafting. Obviously, this needs a lot more work, but essentially the idea is it's going to be a simple endless runner type of game, and I say endless runner in quotes because it's not exactly what you would think of for your typical endless runner. And so basically the idea is you have the typical endless runner aspects of it where you're sort of going along a fixed path and you avoid obstacles, right? And you jump over things or you slide underneath things and stuff like that. But the difference is also going to have the player piloting different types of vehicles, each with their own different kind of abilities. So some will be flying, some will be able to go over water, some will be able to go underwater, and some will have limitations, things like that. And there's also going to be ranged and melee combat between vehicles and enemies that are also kind of alongside you there. And so, we've got a slew of different vehicles here with different types of upgrades available for them, different types of combat type of stuff. It's a little bit like the old Road Rash 3D type of game, if you ever played that, or the classic Final Fantasy VII Escape from Midgar on a motorcycle scene. That little mini game. It's kind of an entire game based around that premise, right? And we're kind of looking at sort of a retro futuristic kind of visual style mixed with like a watercolor painterly / Borderlands kind of style of a game. And so this is basically the list of features that we're going to have to add to our engine before we can actually finish the game. But I think we can start the game without having most of these things in process. So I hope that makes sense. I know that's kind of, like I said, it's kind of the quick and dirty version of it, but that is what we're doing. Like I said, we're in the middle of a pretty massive refactor at the moment. We're completely overhauling the way that our assets and resources are handled across the system. And one of those things that we're in the middle of right now is shaders and materials. So we've just revamped our shader system to work with handles instead of pointers for everything. And the same thing is going to be true for our material system, which we're in the middle of doing that now. And so that is kind of where we left off last night. I did a little bit of stuff off camera, but we're basically picking up from where we left off last time. All right. Yeah, Tammin, it's good to see you as well. Trash Can, it's good to see you as well. Or she, welcome. All right, so I think we're all caught up. So what we're going to do is kind of take a look at, I guess we could take a look at some of the things that I've done off camera. If we do a get status, I've written a little bit of code, right? Some of this stuff is from last stream, right? But the long and short of it is we've done a lot of work around fixing some of the resource issues and some of the various resources like skyboxes, the water plane. Our font system even had some fixes, and it's basically just kind of going through the systems one by one and making sure that they reference our resources the way that they're supposed to. So where that basically landed me was back to the material system. And also our render graph system. So the way that we were handling this before was the render graph node itself, the forward render graph node, was sort of responsible for like holding on to the shaders that it needed to be able to render stuff, as well as being able to apply all the shader uniforms based off of various pieces of data collected from different systems. And we're changing some of that up, specifically the stuff that revolves around materials. And so what we're going to have is we're actually switching from the render graph node managing this to our material system managing this. And so I'm piecing together right now basically a material apply system where we basically pass through a material instance that we want to apply, and then it does it. And of course we have our different frequency updates, like our per frame updates, our per group updates, and our per draw updates that we need to take into account. So basically what I'm doing is I'm moving over the logic from the render graph node over to here as is. And then we're going to actually split those things up so that they are updated appropriately within the context of a frame. All right. So I hope that all makes sense. Okay. So these are the bits, like there's some bits that I'm not 100% sure how I want to handle just yet. And one of those bits is essentially this, the per frame data, right? So we have a bunch of stuff that's sort of global to the world or scene, right? That needs to be applied once per frame to the shader, such as our matrices. We have our our projection and view matrices, our inverted view matrix, our view position and inverted view position, which we might be able to actually get rid of those and extract them from the view matrix instead. And then, a few flags like our render mode, which kind of controls what sort of debug render mode we're in. So we have the ability to actually show, standard lighting mode or lighting only or normals. Actually, while I'm thinking about this, I might be able to actually pull this up, an older version on the Mac. Give me just a second. I might be able to actually pull this up for you guys. Because maybe it would be helpful to see this actually run. Let me just build it real quick. I think the 080 version should work. I just want to actually get it running, and then if it runs successfully, I'll go ahead and swap over to that screen so you guys can actually have a look at it. This does not include all the changes that we've made for the assets and the resources. Okay. So that did work. So let me go ahead and change over to this one. This is the machine that I stream from, but I actually have sort of a second copy of this checked out. This is kind of what it looks like at the moment. There's a few issues and things we need to sort out, but for all intents and purposes, this is kind of where we're at the moment. So we have this is sort of what I would consider the sort of normal view. And then we also have like a lighting only view that only shows lighting data. We have a normals view that only shows normal information. There are some black surfaces here. Those are invalid normals, right? So those show up as black. So this mesh here has got some issues with it, right? But the others are okay. And then this is our cascading shadow map visualization. So we have different color zones according to where we are with that. So we can just kind of see where the cutoffs are for the different zones for that. And then we also have a wireframe view as well. And this really helps visualize the terrain and the LOD system that the terrain actually has. And you can actually see here in the distance where that kind of steps down the amount of vertices that are drawn as you back away from it, right? It might be a little bit hard to see if you're not like maximized, but you can see all the way there in the very corner. It's basically just one quad. So there's that. And then we also have the ability to select and manipulate objects in the world. So we can select like this tree, for example, and move it around or scale it. There's movement there. Here is rotation, right? And then you already saw scale, right? So that's sort of the precursor to an editor, right? And these are all components that we've all completely written from scratch on stream, right? So that's more or less kind of where we're at in terms of progress, right? So essentially where we're going to wind up is here once we're done with the refactor, but our resources are going to be, our resource and asset systems are much more robust, and they're going to allow for us to actually be able to package our assets for a release build into like a binary asset pack so that we don't just have loose files sitting on disk. All right, so that's pretty much where we're at. Diamond, good to see you. MacBook turned on, yeah. Yeah, so the MacBook is actually what I use to stream from. So that's usually where I run OBS, just because streaming from the same machine that you're doing graphics programming on is a bit like playing Russian roulette, right? It's not a great idea. And I've had it actually kill streams a couple times, so. All right. This system here that I'm using, by the way, is Arch, right? In case you were wondering. All right, so like I said, I'm pulling in all of this logic from the forward render graph node for now. And this is going to essentially, I think we should be fine. We may have to split this material system apply up into a couple of steps instead of just one. That's kind of what I'm trying to figure out now. But I wanted to get the logic moved over here first so that we could actually kind of start to investigate that. So this is all the global stuff that only gets updated sort of once per frame. And then over here, we actually have a loop of things being drawn. So the way that this forward render graph node works is if we have geometry, then we actually switch to the what was the PBR shader, which is now going to be the standard material shader. And then it sets the wireframe mode, sets the global uniforms, and then loops through our static meshes and goes through those one by one and performs a whole bunch of local sort of UBO updates based on each one of those material properties that we have. So essentially we have sort of the global level or the per frame, once per frame level. Then we have the per group, which is basically per material. And so we may have multiple objects throughout the world that use the same material. So that's a separate binding level. And then we have the per draw binding level, which is per actual thing drawn in the world. Let's see. Do you do a missing material like magenta? So we have a default material, which right now is just set up to have a checkerboard pattern as the it's like a white and blue checkerboard pattern as the as its base color, right? And then it just has like a default normal texture that it uses. So we're actually going to change that up a little bit. Once we get some of these other effects into our material system, we're actually going to maybe animate that a little bit just to make it super obvious that, you know, there's something missing it wrong, right? Like maybe a bright glowing kind of material or something like that. So we do have that as well. The other thing that I should mention is off camera. I went ahead and finished off a lot of the internal logic that we were talking about yesterday. Most importantly, the sort of default standard material, right? So the way that this works is we basically create a fake asset, which has all the properties of the material that we need. And then we perform a serialization of that into text and then fire that off to the resource handler for materials to actually parse that and turn it into a real material that we can actually pass back to the system and use. So it kind of just makes use of systems we already have. And, you know, we don't have to do what I was initially doing for this one and like code it in a string, right? And try and figure all this out because that's just ugly. So now we can actually just set up a fake asset per se and serialize it to a string and then pass it around. All right. Is it an M1 or M2? It's an M1. I think you mean by the way. Yeah, Arch by the way. Exactly. Amazing stuff. Are there any features of C++ you wish were part of C that would be useful for this project? Yes, two specific features. Operator overloading for the math library would be nice, right? We obviously don't have that. So that would be really nice. The only other thing would be ultimately const expression, which I know is coming in C23, but we're not doing that here. We're using C17 for now. I want to kind of step it back to C99 if I can. But that would loan us the ability to, or allow us the ability to have compile time string hashing, which would be really nice. But yeah, we don't have that. So we're making do without both of those. But if those were, if I had to pick two features, that would probably be them. Yeah, const expression would be nice for sure. What? While you were doing all kinds of cool stuff in here, I'm stuck pulling my hair out with batch files. I understand. I mean, we've done a fair amount of that too, right? When we were setting up our build system, for sure. Batch files and make files, for sure. All right. Okay. So we need to. We probably ought to have like a. We probably ought to have. We have a material system apply. This should probably be apply instance, right? We apply a material instance, which is going to be the sort of per draw type of thing, right? We probably ought to have apply frame, or just maybe just do we want to say, I don't want to say necessarily bind, right? But maybe that makes more sense. Maybe we say bind. Or actually, technically, before even bind, we should probably say prepare frame. So this is what would actually do global stuff, right? Or per frame updates. So prepare frame is basically going to, I think what it should probably do is it should probably loop through our known shader types. And at that point, just go ahead and apply all of this level stuff, right? The per frame, once per frame type of data that needs to exist. And then we have maybe a separate bind, right? So we have, B8 material system. How do we want to say this? Do we want to say bind? I don't know if I like the word bind. So this, I'm thinking, would take a handle to a material, right? And essentially what we would do would be we would bind for that particular material. And this is actually technically the base material, right? So it would be, I'm trying to think if we even need this step. We might actually just be able to do it in a single apply. Now that I'm thinking about it, we might not actually need this. So there's two levels to this, right? There's sort of the base material, and then there's the instance. So maybe when we do apply, we can check to see, has the base material been applied for this particular frame or not? And if it hasn't, do it. And if it has, skip that. Maybe that's the way to do it. And we can actually do that by, we have the material data here internally. Let's see, we could also do, technically speaking, we probably would do, let me think about this for a second. So I'm actually kind of thinking maybe we can just sync it by the frame number, the renderer frame number, right? So we could add something in here sort of as a tracker, like a U64. Right, and this would be the frame number where the group, I guess we could say per group, uniforms were last synced. Right? And so we could essentially apply the per group uniforms for that particular material, update the frame number, and then next time we go to check it, we'll say, hey, these frame numbers are in sync we don't need to do that anymore. And that'll keep us from, every time we call apply, we don't necessarily have to have 3 levels of it, right? We could just have like a frame prepare and an apply. And the prepare frame would essentially be all material types at their global level. And then, so yeah, this should go up here. And we'll come back to this, obviously. We have some stuff that we need to get for that now. And then here, when we're actually looking at the material instance itself, all we have to worry about is the per group, right? So we could literally say if base material render a frame number. Let's see. Do we have a way to say, I wonder if we should just pass it in. Pretty sure. Shader apply per frame. It looks like we do actually just pass it in other places that we handle this. So maybe we just do that so we don't have to worry about actually grabbing it from somewhere here. So we'll say U64 render a frame number. Okay, and so if these two things are not equal, then we do the update. Right? Otherwise we skip it. So only do if this, if the material hasn't been synced this frame. Also, we should have a to-do in here. Only do this if the material base, or the base material, I guess we should say, is dirty. Right? So oops. So we don't necessarily need to do this every single frame. We really only need to do it if something on the base material has changed, which is going to be a bit of an exception, right? It's going to be dirty when we first load the material. But once we actually get past that point, I don't think we need to actually reapply this all the time, right? Because that data is already going to be in the UBO, already uploaded. All we'll have to do is bind it, essentially, before we actually complete our draw, right? Okay. So let's just scaffold this out. Update group uniforms. And then here we need to apply group uniforms via the renderer. And actually this is just going to be shader group, right? So we need to do that, and then we need to bind per draw update uniforms if dirty. Oops, God, I can't spell tonight. And then apply per draw. Right, so we actually are kind of missing some steps here. We should do bind per draw. Right, that should always be done. The only difference is whether or not we actually need to update the uniforms. Oops, this should be group. Okay. might actually be able to combine these two steps, so we'll see. I'm just trying to think of how the basic flow of logic should go. I think that makes sense, right? So this happens once per frame. That kind of makes sense for it to be on a different at a different level, right? I guess let's sort this one first up here, since we already kind of started on it, right? So I'm actually going to grab pretty much all of this stuff. And let's see, we only have state to worry about. We don't need instance data. We just need to essentially loop through our individual material types, right? So we actually don't need material for that. All we really need to take a look at is the shader, right? So actually, instead of a switch, instead of that switch, we're going to do standard shader type. We're just going to basically update them one by one, right? So I'm going to scope this. Oh, wait, I already have one down here. Right. We'll have to figure out where all this data comes from. We'll have to probably, let's see, prepare frame. So that's prepare frame is going to have to include several pieces of data. So the real question is, do we want to have individual like set functions for that, which kind of sucks, or do we just pass it in as one big struct from somewhere? Although if we pass it in as one big struct, then we don't really have a way to track what's been updated. So maybe individual set methods are the way to go, and we can track dirty state from there. Okay, so we do the standard shader. Before we actually do anything else, we need to say shader system bind. Do we not have a bind global? I thought we did. Didn't our backend have that? Bind per draw, bind group, bind per frame. Do we not have? I thought we could have. I could have swore we added that to our. Per group. Nope, we didn't. How did I miss that? Okay. So really what we need to do here is we really are talking about just binding sort of the per frame specific update frequency for that particular shader. And all this is actually going to do is let's see, I guess we could just do return renderer shader bind per frame. Renderer states, and then the shader itself is just going to be that. And that's actually all we need to do. We could probably go ahead and validate that the shader handle isn't like invalid or something. So we can say if khandle invalid, is invalid shader, or khandle is stale. That's going to require that I go to shaders, sub shader, handle index, unique ID. Okay, so if we have a stale handle or an invalid handle, we should probably bleat about it. Try to bind frame on a shader that's using an invalid or stale handle. All right. So that's that. We need that. And then we'll go to the header file here. And, oh, I nuked the B8. Whoops. Okay. I'm just going to take this comment, copy it, binds the shader at the per frame frequency for use must be done before setting frame scoped uniforms. And this actually says instance. Is that correct? I think we have these that might actually be wrong. I'm not 100% sure. Thank you for the follow, by the way. Appreciate that. Welcome. Standard Pointer, how are you doing? Lovely. Good to see you as well. Let's see. Sick of complicated build systems? Yeah, that's why I built my own. And it's pretty simple. I'm actually looking to simplify it a little bit more, if I can be honest. But okay, so all of that to we actually need to bind this shader, right? So we're going to do shader system bind frame, and we're going to pass in the handle for shader. And I suppose if we fail that, we should bleat about it too. Failed to bind frame frequency for standard material shader. And then I'll return false. Okay. So we bind that scope. We probably also, let me think, do we need to actually use that at this point? Do we actually need, I don't think we do need to use that. Uniform set by location. Okay. Let's do, I think we have to actually use it until we're actually ready to like draw with it. So we have bind per frame, which technically is a no-op for Vulkan, but I'm calling it anyways, because our other backend APIs may not be the same. So the only thing that I think we have to do I think per frame the binding isn't as important. Per group and per draw it definitely is. Okay. So I guess we'll kind of stick with it though, right? So we have our bind frame right there, right? So we sort of bind our shader frequency there. Here we apply the uniforms for that frequency, and then we apply that frequency, right? Which is also, this should be per frame uniforms. Thank you for the follow, by the way. Appreciate that. Welcome. Hope you're doing well tonight. All right. So this should be that. Again, we're just pulling this code from this forward render graph node, so it's got some issues here we have to sort through. Okay, so the question becomes, where do we store these global items? I almost think in our material system, we actually have our material data here. And I'm kind of thinking like this is probably where that state belongs for that particular material, right? Maybe we could create a separate structure for it just to hold that stuff. But that is more or less what I'm thinking. And then what we'll do is we'll provide some defaults there, so it'll just kind of work, even if it happens to be, not correct. And then we'll expect the user code to sort of update that, right? So that way we at least have somewhat sane defaults in the state, in the sense that, if somebody does something stupid in the application, this will at least handle it gracefully. So I think what I'm going to do is grab the only bit that we have to hold on to is essentially non-texture, non-sampler uniform data, right? Anything else beyond that is actually... Wait a minute. We might not actually need to do that. We might actually just be able to write directly and not even have to store it at this level. Maybe we should, in the sort of setter functions for all of these, maybe we should just write it right then and there. It seems error prone though. So it's got to happen in the right spot within the command queue. No, I'm going to keep a copy of the data and then upload everything at once. The other thing that we probably should do at some point is get rid of like half of these uniforms and just convert the whole thing to be a struct, so we could just slam over all the data at once instead of doing it piecemeal like this. That would be a lot more efficient anyway. So I think I'm going to keep the format as is for now, so we can kind of stitch things back together. And then once we have it up and running, I'll make that change. Okay, so we need... I'm actually just going to copy this stuff for reference. Because I kind of know off the top of my head what all of those different fields are. So I think what I'm going to do is material data. I'm going to have to make a separate struct for this. It can't be in the material data. Well, I guess the global stuff, that wouldn't make any sense anyways. It really should be alongside of our material data. Right, so what we're really going to wind up with... Thank you for the follow, by the way. What we're really going to wind up with is a type def struct material standard frame data. And that's where all this stuff is going to live. Obviously not all of this stuff, right? But so we're going to have a mat4 projection, mat4 view. I guess we could call it view matrix, just to call this matrix as well. It's kind of unnecessary though. Let's see. We also have, there was a couple more in here. I think there was an inverted view matrix. So mat4 inverted view. Okay, and then we have a vec3 view position. Oh, you know what? There's two of those. And then, right, I forgot there's two views as well. This should be views too. Incidentally, the reason that we have two views and two view positions, and we probably need two inverted views. We need two of the inverted ones too, I think. No, ignore me. Okay, so we have view index 0 and view position index 0 are the normal ones. View index 1 and view position index 1 are the inverted view and position. So maybe I should just, yeah, let me undo this. Let's call that view, and we'll have view position, and then vec3 inverted view position. Can shorten this a little bit. Okay, then we also have a U32 render mode, right, which doesn't really need to be a U32. We could probably shrink that or pack something else in with it. And then we have the cascade splits, which I happen to know is an array of vector 4s. So that's a vec4 cascade splits, and that essentially defines how those splits are in space. So I know we have 4 of those. Okay, so that's that. All right, so we also have the directional light spaces, which is the light space matrices for all 4 of the cascade splits. That is for the directional light when we're generating the shadow maps for the cascaded shadow map. So that's a mat4 directional light spaces, and that's also 4. We are hard coding the size in there, but I'll create a constant for that in a bit, so it's clear as to why that is. So that's that one. Actually, let's just do that, right? Keep the comment, I suppose. Global shader options. Okay, so we have use PCF, which again is a U32. So that one we could probably again combine with something else. And then we also have an F32 bias. And finally a clipping plane. So vec4 clipping plane. Okay. So this is all of the material sort of standard frame data, right? It's the frame specific data. So what we can do is, I guess we'll put in here right next to the shader locations, I suppose, material standard frame data. And we'll say material standard I can't call it material frame, standard frame data. I guess we can say standard frame data. All right. And what we can do is grab this and when we actually set up the shader itself is where we can actually set up the state for this. So what we can do is, I'm just going to do, let me get rid of this. State standard frame data dot. Okay, so projection is going to be mat for perspective. FOV radians. What do we want to use for that? 45, I guess. Aspect ratio is going to be, I'm just going to default to 720 divided by 1280. Near clip, I'm going to say is 0.01f. Far clip, I'm going to say is 1000. Right? And that way we've got sort of a reasonable default for that. View is going to be mat for forgot the equals. I was wondering why my IntelliSense wasn't working. We could do a look at matrix and we'll do vector 3 0 for the position. The target, I don't know if this is going to be valid, but we'll also say is vector 3 0, and then up is vector 3 up. Right? And I think actually we need the inverse of that. But then we also need the inverted view as well. So I guess we could generate the inverted ones first. And then we can do this one. This one is mat for mat for inverse of state standard frame data invert view. All right, so this one, the position is just going to be vec3 0. This one is also going to be vec3 0. Render mode is going to be 0 by default. Cascade splits. I'm going to have to set these individually. Technically speaking, these are all going to be zeroed out, so I really don't have to do this. But I guess to be explicit, right? We're going to wind up replacing this the first time we go to render anyway. That should be vector 4 0. I guess I could loop it, right? Because I could create the directional light spaces at the same time. So for U32I equals 0, I is less than 4 plus I. Encapsulate both of those. Change sub I. This will also be sub I. And then this will be equals mat for identity. View position. Oops. Forgot those. Okay, use PCF. We're going to default that to 1. Bias is going to be, I think we had that hard-coded somewhere. Where was that? I think that was right here. We have sort of a hack in there to read that in from somewhere. We're going to fix that hack too. Okay. Clipping plane, I'm just going to set to vec 4 0. All right. And that's sort of the frame specific data. Per frame, actually. Data for the standard shader. Now, obviously, these values are kind of BS, right? But at least if we were to render with this, we would actually get something that's halfway correct. All right. Let me catch up on chat. Hello, I'm new to game engine dev. Currently learning computer graphics with Direct3D 11. Nice. Kind of struggling with engine design. Any tips? Yes. One of the things I always say. Is this book right here is one of the things I always recommend. It's Game Engine Architecture by Jason Gregory. It's a fantastic book going over all the systems that are typically included in an engine. Read this though, bearing in mind that it's kind of geared towards Naughty Dog's like specific engine, so it's not like something that's going to fit all scenarios, right? But it'll still give you a good idea of what all those different systems are, what they do, how they kind of work, how they interact with each other, stuff like that. I've read through that book a few times, several times at this point, and I would recommend that you do the same over time, right? That and studying open source game engines as well, as both a resource on what to do and what not to do. You could do it the hard way, screw around until it works. Yeah, that's fair enough. I would say that's probably going to be the best way to learn once you understand the basic concepts to really drill those in into your brain. Definitely getting in there, getting your hands dirty, and actually writing stuff is going to be the way to learn and get that to stick, right? Spiro, by the way, thank you for handling that mod term there. I appreciate that. How's it going, buddy? Exactly what I'm doing right now, but learning from others' wisdom is a good thing, right? Yes, I would agree with that for sure. Chili Tomato Noodle has great videos on Direct3D 11. Yes, he does. I don't know if he's done 12 at the moment, but yeah, he's got a lot of stuff on Direct3D 11. I would probably do some things different at the engine level that he's done. He tends to go in a very object-oriented programming heavy route, which I'm actually steering more and more away from these days, but other than that, it's really good stuff. His video is more like he's actually implementing it, just need the design stuff, I'll code it myself. Yeah, and that's, so if you're interested in more of the design stuff, this is going to be the book for you for sure. Yeah, no problem. Would you also suggest that book for someone that has no experience with low-level game dev and graphics dev? I'm going to say yes, and here's why. There's a lot of it that's going to go over your head, right? But there's a lot of it that's going to make sense to you too, because while there are code examples of things in here, there is a lot of good information on how things are actually structured as well. So it's not all just like code samples, right? There's a lot of it that actually like kind of breaks things down for you graphically, right? Or there's a lot of tables in here. Things like allocators, memory management, right? How that works on a high level. There's lots of good information here outside of just the actual core programming stuff. So it's a good high level overview of it as well, but there's a lot of details in there as well, so it kind of fits both paradigms. I think it's a good overview as well. It'll also give you a little bit of a primer on like how CPUs work, how memory works, things like that, so that when you do jump into the programming stuff, it'll click and you go, I remember that. So, read it understanding that a lot of it's probably going to go over your head, and that's fine. You're probably going to have to read it more than once, and that's also fine. But yeah. Spiro, why are you here? Spiro is a mod, yes. He will use his powers. Which book is that? So this is Game Engine Architecture by Jason Gregory. And for context, he's a game engine dev at Naughty Dog, or at least he was. I don't know if he still is or not. But when he wrote this book, and this is the 3rd edition, when he wrote that book, he still was. So I assume he still is. Sounds perfect. Just ordered it. Yeah. I mean, mine is well used and full of bookmarks and stuff. You can kind of tell it's beat up because I've read it a lot of times. Worth every penny, for sure. Max, good to see you. How are you doing? Chili is a great teacher. Yes, I agree with that. Is mayonnaise a material? I mean, you could make a mayonnaise material, technically. Let's see. Just getting started this game engine. Currently learning computer graphics. Oh, wait. Is that the same question from the other side? It might be. It's almost the same question. No, it is actually the... Yeah, you're the same person. Okay. So I already answered that one. From Lake, good to see you as well. In your game, if you had to make a homage to a cartoon or anime character, who would it be? Probably One Punch Man. Because why not? It was ridiculous and funny. And funny because it was ridiculous. There is no exclamation point book. But what I can do... What I'll do is I'll shoot you an Amazon link. I'm not like affiliated or anything, so I'm not like making money off of this. It's just the first one I found. But that's the book there if you're looking for it. I should probably put an exclamation point book command in there with that link, but yeah. That's the book. You could probably find it cheaper elsewhere. I'm just looking at that. I did not pay $75 for it when I bought it. I think I bought it used. So you probably could find it cheaper than that, for sure. Okay. Okay. I think I'm caught up on chat. All right. So, this has Nan written all over it. Yes, it definitely does. Some of these things are complete rubbish values, right? But at least there's something there. This one's actually kind of bad. This should probably be like, we should probably use vector 3.1 for this one. That's a little bit better anyway, I guess. I don't know. These values are going to be overwritten anyways, like I said. We just need somewhere to actually store them. Probably a forward vector at least. Yeah, exactly. Like, well, I suppose I could do that, yeah. All right. So that's good. Now all we need to do is apply them. So we actually have, I feel like this is kind of, these lines are getting kind of ridiculously long, but okay. All right, so internal data, this is going to be state, standard frame data, projection matrix. Or I think it just called it projection. Yeah. Okay, so state standard frame data dot view position. I think that's actually spelled differently now. I think I abbreviated it. So I'll just put this here, and I think I abbreviated this to INV view and INV view position. Okay, so those are set. That to do is gone. Now, max shadow cascade count. That is sort of a specific thing to the shader that we're using. And I think that is okay to actually, I think as long as we manage all that stuff in here, I think it's actually okay for us to go ahead and define this internally so that it's not actually used anywhere else. So I guess I'm going to define it as something else, though, so that we don't, so we can actually remove the references to that other one. So we're going to say, let's see, we want to use this for our, if we think about our lighting models, we have unlit, so it won't use it. We have our PBR, which will use it. We have Fong, which technically could use it as well. So I guess I'll call it shadow cascade count. Because it's not just a map count, right? It's max shadow cascade count. Theoretically, you could adjust it to make it less than that, but I think I'm just gonna go with shadow cascade count, right? Incidentally, in our data structure, where we had those 4s, I'm going to replace those now with that. And also, I think it was, didn't we also have one more right here? There we go. Okay. So at this point, we're basically setting the light space uniform locations. So this is going to be state standard frame data directional light spaces sub I. And you'll notice here that we are using light space 0, right? But the locations for these are actually all in order. So the locations for those are going to be sequential. So we can actually do plus I within this loop, and it works just fine. Okay. Use PCF. Oh, you know what? That is a renderer option, so we actually don't need to store that. We don't need to store that here. Bias maybe should be a renderer option. I'm not 100% sure where I want to store that yet. So I'm actually going to take this. Let's actually go back up to here and put this above bias. Get rid of that, and then wherever we get this from, it doesn't really matter. So state, standard frame data, bias, and then clipping plane, right? So that's going to be state, standard frame data, clipping plane. Okay, so that should handle the standard shader type globals, right? We'll obviously have other ones to handle as well. So I suppose we could to-do those, right? So let's see. The other shader types we have is water, and to-do blended. Those are the other two material types that we have right now. Obviously, we're going to have more than that, but those are the other two. So I'm going to get standard working first, get all that set up, get all that hooked up, and then I'll switch back to water. And we'll create the water material type, get all this stuff out of the water plane into here, and then we don't have to worry about that either. All right. So during the apply, we do need to bind the group, right? So we're going to say, do we have the base material? We do. Okay, so shader bind group. The shader is going to be instance material. And then the instance ID for that, which actually I don't know why that's saying instance ID. I need to fix that. The group is actually going to be the base material group ID. And we need to, I believe, check that to make sure we're successful. Failed to bind material shader group. And then we're actually just going to boot out, right? All the weird indenting, by the way, I'm just going to solve by doing this. Okay. So we have the bind group. I think that's fine to do every single time. We don't really necessarily need to worry about that. What we need to worry about is the updates. So, that is the way that this render graph node works is a little bit funky because it has to kind of shift between shaders and stuff. So we're going to try and simplify that as well. Once we get all of this actual shader code out of here, we're actually going to try and simplify this logic a little bit. So here's the group bind. Okay, so this is what I'm looking for here. So we need all of this essentially. And this is going to be in here. Now, we don't have this macro in here, and I'm not going to bother checking these for right now. Okay, directional lights gets... we're going to have some work to do in here too. Okay, point lights going to be the same thing. Let's just get rid of this. Thank you for the follow. Appreciate that. Okay. So, I think the fastest way to do this is going to be a find and replace. ID. This is going to be replaced with state. What did I call that? Material standard shader, right? Oh, it's actually just shader. I abbreviated it. Forgot about that. Globally. Okay. And then we have PBR locations, which is actually going to be standard material locations, state standard material locations. So put that in there first, and then we'll change this, which was PBR locations. And we'll apply that also globally. And then all of these individual M properties. So that is something we don't have anymore with our new material system. Okay, we're gonna have to figure that one out. So what properties was basically a do we even have an example of it here? No. We don't, because the structure doesn't exist anymore. Properties was basically a structure that contained a whole bunch of material uniform data at the group level, and we don't have that anymore, so we're gonna have to build that. Okay, so this is gonna be a to-do. Build group properties and bind it here. We'll have to take a look at the actual shader itself too, so that we can actually, figure out what all we need to do there. Okay, so the other thing is textures. So for this, shader system, uniform. Okay, so for this guy, we actually have a texture array that used to be like using this old texture map structure that doesn't exist anymore. We did away with that, but the texture array still exists, and we don't have these indices. So I think what I might do is grab these, because they're still relatively correct, although they're not samplers anymore, they're textures. So I'll have to fix that. So I'll have to rename these too. Let's say let's go with matte standard IDX. And this is base color. Combined is no longer a thing. This is MRA. Kind of the same thing, but not fully. And we're also going to have to think about, these are textures, by the way. We're also going to have to think about, we have the MRA, which is material roughness AO, but we can also have those as separate maps. So I'm actually thinking we should do metallic, right? Roughness and AO. All right, and so this is going to be 3, 4, 5, 6, and 7. We also should go ahead and just put in emissive in here, because we're going to be adding that as well, so we might as well just get a slot reserved for that. Okay. Okay, so the shadow map, that is technically an array texture, right? A 2D array texture. So that'll have 4 layers in it, right? And then the irradiance map is a cube map, essentially. So those two are handled a little bit differently from the rest of these, but the rest of these are texture indices, right? So those are essentially what we have to bind here. So I think the way that this is going to work is we have our material textures, right? So this is going to be, I suppose we could actually just go ahead and do material texture IDX, right? And this is going to be, wasn't it? Base color, wasn't that? It was matte, that's why. It's probably why I shouldn't abbreviate, but it's internal, so I'm not really that worried about it. Oh, matte standard, not texture. Apparently have the memory of a goldfish tonight. Okay, and then this isn't combined, this is MRA. Okay, so basically what this is saying is the uniform location is the same for all of these, right? But we are binding different textures to that texture array, which is all the same uniform, but we need different indices of it. So this is the first one, second one, fourth one, or whatever it is, fifth one, I think. And then to that, we're going to bind the appropriate maps, right? So the way that we're going to work this is we're probably only going to do these bindings if we actually have a texture there, right? And if we don't have a texture there, we're not going to bind it, and we'll just use sort of the default that was provided there. So the Vulkan renderer automatically uses a default texture in the case that we don't actually have something assigned and that descriptor never actually gets updated. It does that. So what this is going to be, let's get rid of this. What we're really looking for here is material. Material. What did we call this? base material. Base material. We want to actually use the texture itself, right? So base color texture there, right? So this is going to be base material, normal texture, base material, MRA texture, right? And don't forget that we also have the individual values to use from that as well. So what I think we're going to do here is for each one of these, we're going to say if base material, base color texture, then we'll do this, right? And then this one, base, normal texture, and base material, did we convert this to flags already? I think we did. Yeah. So let's do flag get, right, which is just a quick check to see if a flag is enabled. We'll do base material. Thank you for the follow. Appreciate that. Welcome. Flags, and then we're going to check it for material flag. And we want normal enabled bit, right? So we have two things to check here for the normal map. First off, do we have a normal texture? And second off, are normal maps enabled? Because we can have we can actually have materials where it's not enabled, right? So if it's not enabled, we're not going to bother setting it. Okay, so the next thing is it's going to be a. I think it's actually going to be almost identical. Instead of normal, it's going to be MRA enabled, and then it's going to be the MRA texture. Okay, so we have that. So if MRA is enabled here, then we will use the MRA texture. If, you know what, let's actually extract this real quick because we're going to need this to check something else. Thank you for the follow. Appreciate that. What is a shader group? Okay, so thank you for the stretch redeem, by the way. So let's see. Why would you assign a normal texture if you're just going to disable the normal flag? I'm not disabling the normal flag. I'm checking to see if the normal flag is enabled, and then I assign it. Unless I've typed something wrong, which is possible. So a shader group is a what we call a shader update frequency, right? So there's 3 update frequencies for a shader. And when I talk about update frequencies, there are, it's basically the times within a frame, an entire frame of everything drawn on the screen, that a shader gets updated in terms of uniforms. So you have what we call per frame, which is once a frame, those uniforms in that shader, those per frame uniforms get updated. And that's for the entire frame. No matter how many different kinds of materials we draw, no matter how many different instances of that thing we draw, those things are only going to be set once per frame. And then we have a group, which is in this case, the individual base material itself. So the base material is what contains all of the properties for a specific material, like a wood material or a metal material or something like that, right? It contains the texture maps, it contains additional color data, flags, all that kind of stuff, right? And so those uniforms are updated once per material that you have, right? So if you've got 2 different types of materials in your scene, then those uniforms would be updated once for each of those material types, right? Or those, once for the metal and once for the wood material, for example. So that's groups. And then we also have per draw, which is essentially every material instance, right? And so a material instance, as opposed to a base material, is it basically has additional properties that get modified per object that you draw. And it can also have properties that override the base material, right? So let's say that you have, I don't know, I guess this is not the greatest example, but let's say we have, we want to use the same metal texture for two different static meshes, right? But we want to animate the UVs, or, maybe the texture scale or something like that, on one of them, but not the other, right? You would need to modify that at the actual per draw update frequency, right? Another per draw update frequency thing is also the model matrix, right? So you need one of those for every draw. So it's avoiding redundant work as you render out your frame. Yes, but it also saves us memory, and also prevents us running into issues. So the way that descriptors work in Vulkan, which is ultimately what these uniforms are tied to, is they can only receive updates until they're actually bound, right? So there is something called update after bind, and I'm not going to go into that for right now, but I'm not supporting that, right? So standard Vulkan rules say that you can only update a descriptor once until the draw actually happens, right? And there's a little bit more to it than that. It's technically not even per draw. It's technically within the context of a execution of a command queue, right? Or a command buffer queue, right? Within a queue. So when you have per frame descriptors, right? There's one set of those per frame descriptors. When you have per group descriptors, there's one set of those descriptors per group, right? So we have one set of descriptors per material of those uniforms, essentially, right? And those descriptors are basically just memory pointers under the hood, right? So we have a set of pointers for the wood material, a set of pointers for the metal material, and that's the way that works, right? And then the per draw one can either have a set of descriptors per individual instance of that thing, like per material instance, or we can use push constants, which are essentially a special type of way to immediately push updates to shader uniforms, right? But you're very limited in terms of size on that. The Vulkan spec only guarantees you 128 bytes of push constant space. And right now, 64 of that is taken up by our model matrix, right? Which there are better ways to do that, arguably. But obviously, we can't just shove everything into a push constant, right? That's not going to work because a lot of devices don't support that. They're not going to support that very large. So we have those different sets for a reason, because we need different numbers of updates at per execution of a frame's command buffer, and we're only allowed to update those descriptors once within the context of that entire thing. So you have to sort of stand up all these resources for all these different levels and manage them, and that's essentially what we're doing. So yes, it avoids redundant work, but also because we have to, because of the way that Vulkan works. Otherwise, theoretically, I could create a set of descriptors for all the descriptors all the way down, for each instance of a material, but that would be wasteful, right? Because then we'd be applying something like a projection matrix every time we have to draw an object, which is super wasteful, right? Didn't realize Vulkan limited some of those binding updates. Yeah, so there's hardware limitations in that, specifically around push constants, right? Because push constants are a very specialized thing. So what most people use push constants for is indexing into an array for a specific thing. So probably what we're going to do is we're eventually going to have a storage buffer that has all of the model matrices for an entire scene pushed into it, and then our push constant will just contain an index into that array of things. We could just pull it that way. But we don't have storage buffers in here yet. We will at some point, but when we do, we'll probably do that. But yeah, I hope that makes sense. I might have gone a little bit deeper than I needed to, but I hope that explained everything. Have you tried descriptor inline blocks yet? No, I have not. Because I don't think support for those is all that wide, if I remember. I think that's still a fairly new thing that a lot of devices don't support. If I remember correctly. I might actually be mixing it up with something else. Now I want to buffer overflow to cause a panic. Wait, what are you guys talking about over here? Oh, okay, you guys are nerding out over there. Let's see. That book seems like a lot of information to take in, especially when just getting started. Do you think there's a smaller starting point? It's better just to climb the bigger mountain right away. Thank you for taking the time to answering the questions. Okay, so it is a lot of information, not going to lie. But when you're talking about getting into graphics programming, there's not really like there's not really a way around it. There's only a way through it, right? There are other resources that you could use that kind of skim the surface on some of these things. One I usually recommend a lot is this one, which is learnopengl.com. So there's a lot of really good graphics programming specific resources in here, and how things work and how to actually stand stuff up using OpenGL and concepts and some of the math and that kind of stuff. So this is actually a really good site. Even if you're not going to be using OpenGL in the long term, or you're using DirectX or whatever, there's still a lot of concepts in here that translate well. But if you're talking about game engine programming, and actually making an entire engine outside of just the renderer, which is basically what this includes, then yeah, that book is where it's at, basically. Because a game engine is a collection of many very complicated systems, and there's not really a way around that, but only through it. So I hope that helps. Game engines are the crossroads of many disciplines. You aren't kidding about that. Yeah. Descriptor inline blocks have been around since Vulkan 1.1. Yeah, but what about the hardware support on those? Like I said, I might be thinking of something else. But I question the hardware support. Because even if it's around since Vulkan 1.1, that doesn't necessarily mean everything supports it. Let's see. You can get loads of hands-on experience with graphics programming without necessarily making an engine. That is true too. Yeah, it depends on what your end goal is, right? So if you just want to make a renderer, Learn OpenGL is where it's at. Go there. You'll also need. You'll also want. I've heard that this website is pretty good, learncpp.com, which is directly linked to from Learn OpenGL. So if you want to learn C++ and or C, right, this seems like a pretty decent place to start as well. And this will last you for quite some time, for sure. But yeah, it really depends on what you're trying to do. If you're wanting to make an entire game engine, that's cool. If you're really only just wanting to make a renderer, that's a little bit different. If you're looking to make a super simple renderer for like a very simple kind of game, like a 2D tile-based game or something like that, then you probably don't need something too complex, especially not, what we're creating here. Depends on what you're doing. That's the site you use to learn C++? Yeah, I should look at it. I haven't looked at it in a while, but I learned C++ the hard way. That stuff didn't exist when I was learning C++. Let's see. Let's see. Obligatory Handmade Hero mention. Yes, so Handmade Hero is a great series as well. That's, in fact, I mentioned that right here on the homepage, right? Boink, right there. So Handmade Hero is a really good resource, especially in the beginning of the series where he goes into like how processors work and how memory works and an intro to C and all that kind of stuff. That's a really good resource for that, especially setting up some of the early on systems. As far as I know, it's still on hiatus. He's not finished the game. And he's like 600 something episodes in, I think. And, you know, he kind of wanders around on a lot of different topics, a lot of really cool topics. So you may have to pick and choose which ones you actually watch out of there. But yeah, that's a really fantastic resource to look at as well. And a lot of it's cataloged with like links to timestamps and for questions and things like that. So Vulkan is fun. Yeah, Vulkan is fun. How do you even get started with this low-level stuff? Seems large to bite into. Yeah, you don't want to bite into it all at once. Definitely not, right? It's taken me well over... Well, let me think about it. It's taken me 2 decades to get this far, for sure. But that's also not going at it full-time, you know? Yeah, basically what I would say is figure out what it is that you want to do. Do you want to make a game or do you want to make engine, right? Or do you want to do both? Figure out what it is you want to do. Figure out what platforms you want to support because that also makes a difference. Do a little bit of research into, you know, what you need to learn to actually make something on that platform, depending on what you want to make and where you want to make it. And then whatever tech stack that is, whether it's probably going to be C or C++, learn that language decently well, have a decent command of it, and then step into the graphics programming stuff. Take it in pieces, right? Don't just like jump straight in and be like, I'm going to learn Vulkan and C at the same time. Like, that's not going to work. Something small that you can finish, like Hangman or something. Yeah, exactly. Or even simpler than that, like just a text-based game with like menu-driven options where you like press 1 through 4 from these different options, you know, like an old like the old text-based games you used to see back in the day, like MUDs or something like that. Only used C++ for code forces. Still don't have the confidence in building an actual project, and the only way you're going to get that confidence is to actually use it. So one thing I always like to point out is like you can look at tutorials all day, you can read articles all day long, but until you actually get in there, get your hands dirty and start writing some code, and then throw out your code and write it again, right? Until you actually get that repetition in there, it's the same way you learn a language, right? You just keep repeating it and keep doing new things in that language, and that's how you get better at it. You're not going to pick it up by just reading a book alone. You've got to get in there and actually do the thing. Let's see. You guys are bagging on the Foley over here. Oh, there's all kinds of skullduggery going on over here, it looks like. Got baited into rewriting your project by a bot. That's too funny, guys. I can't catch up on quite all that chat, but yeah, that's very funny. Okay. Let's see. Where were we? Only if the base material is dirty. Yeah, we can conditionally do that later. Okay, so we probably ought to... We have the normal texture here, the MRA texture. We should probably also put in the other textures that we have. So we have metallic texture. And I think we have a metallic enabled. Maybe not. Looks like AO and emissive. Okay, so we don't actually need this flag for this. Oops. Right, so if we have metallic texture, then in the metallic slot, we bind the metallic texture. We're going to do the same thing for roughness texture. So roughness texture. And then actually I'm going to copy this one as an example. We need the AO. So AO texture. And we need AO enabled bit, and then, whoops, AO texture, okay? Now, these three are only going to be used if we're not actually using MRA enabled, right? So if MRA is in use, then we ignore those other ones. So let's actually cut this out and go to right here. So we'll say B8 MRA enabled is equal to that, right? And then we'll say MRA enabled here, right? And here we're going to say if not MRA enabled. Then we'll do this. And actually we could just do an else here. And whoops. And I keep hitting the wrong key. Right, do that, and then we don't need to check this MRA enabled here. Okay. So if we don't have MRA, I guess I could have flipped those around. That probably would have made more sense, actually. Let's actually do that. It's a little easier to follow. Okay. So, we only use these textures if MRA is not enabled. Otherwise, we go ahead and use the MRA texture. And there's a little bit more to that we're actually going to have to investigate. So, let's take another copy of this, come down here, and we're going to do emissive. So emissive, right? And this is going to be emissive. And this is going to be emissive and emissive texture. Okay. And actually we need to change up 2 of these. Because this is how we handle the textures, right? But don't forget there's also an accompanying value that we can actually specify in the material configuration as well. So for each one of these, we can either specify a texture or we can specify a value. So I guess the first one we'll check out is the base color texture, right? So if that's not defined, then we need to do shader system uniform set by location. And I don't actually think we have a location for that yet. So we're actually going to need to get that. So we'll do shader and then standard material locations. And instead of material textures, let me think, how do I want to do this? We probably ought to have a different uniform for these. So the base color right is just going to be base material base color, which is a vector 4, right? We don't have a material location for that yet, right? So we're actually going to need, I'm actually going to go in here and just actually go, I'm going to grab all of this just as a reference. Just these things here, okay. And then when we're actually setting up our material locations, we need a couple more things. So I guess I'll just tack them down here at the end. Right. So what we're going to do is we're going to put in U16 base color. U16, these are the locations, right? Not the actual values themselves. So we're going to need one for base color, one for metallic. One for roughness. One for AO. One for emissive. Refraction texture I'm not going to worry about yet. We're going to cover that when we actually get to the water material type. So U16 MRA. Let's see what else. We also have flags, right? So that's going to be, we're not actually sending that through. We need to send that through. And then UV offset and UV scale. UV offset, U16 UV scale. All right. So what we'll do is I'll take a copy of this again, or I'll just honestly just cut this. And we have actually I think this is all we need. Okay. So set by location. Oh, I think this needs the address of this. There we go. Okay. So essentially the way that this works is for our maps that we are always using, like base color texture is always, or base color is always going to exist in one way or another. It's either going to exist as a texture or it's going to exist as a value. So if the texture doesn't exist, we fall back to the value. The same is going to be true with the normal texture, but only if it's enabled. So we actually need to pull this out and do this. Right, so if it's enabled, we're going to do this check, right? So if we don't have a normal texture, then we're going to essentially do this bit, except this is going to be just normal. Or is it? Do we not actually have? Maybe normal map is required for this one. I don't remember. Do we not actually have? I thought we had a normal value that we could use. We don't. Did we not? Yeah, we do have it in our asset, but somehow it never actually made it over to this side. So it should exist there. Right. So we have that, which means we also need one for the locations. Let's put it right here. Okay. Now, obviously, like I said, we're gonna wind up condensing a lot of those uniforms, right? We don't want them to be all separate all over the place like that. We're gonna combine some of those in the same way that we do for flags, even in terms of what we use where. Okay, so that's normal. MRA also has something similar. So MRA, and then metallic also has. Oops. Roughness. And also I'm just going to paste this down here as well and come back to it. Roughness and AO. Okay. And emissive is the last one that's going to behave this way, so... All right, so we have an emissive value there that we can use as well. Now, some of these only actually accept one channel. And those would be like metallic, roughness, and AO. In our source for our material, we can actually specify a channel that we want to use with that, right? So if we're supplying a texture, then we also need to supply a channel. Otherwise, if we're supplying just the numeric value, then that's fine. But we need to supply the channel otherwise. So new uniform for that. And what we're going to say is U16 metallic source channel. Roughness source channel. And AO source channel. And those are basically just going to be 0. It'll be 0 for red, 1 for green, 2 for blue, and 3 for alpha if we have something that's using it. Oh my God, Spiro, what are you guys talking about over here? Spiro is the wholesome mod. Negative Pointer, how's it going? Good to see you. Welcome. Is it better to store MRA as an RGB24 texture instead of 3 R8 textures? So, the reason that we have this is for flexibility, right? It's always going to be more efficient to use the MRA texture that's combined. But what I'm thinking about here is we're eventually going to have a scenario where we have like an editor. And in that editor, you're going to be able to like browse on disk for a texture map that you're going to be able to use. And then you'll also want to be able to say which channel of that data do you actually want to pull for that specific thing. So if you use an MRA texture, that is saying metallic will always be red, roughness will always be green, and an AO will always be blue. But we have the ability to specify 3 separate maps for that as well. Like I said, it'll always be more efficient to use the MRA combined texture, but you don't necessarily have to. So I hope that makes sense. All right. Okay, so if we are using specifically these guys, so I'm actually going to copy this, and I'm going to come over here and say metallic source channel. We're going to say metallic texture channel. Okay. So this texture channel, if we look at this, is just RGBA, right? So they're actually in the order that we would expect anyways. So we could just pass that through as an integer, basically, and then use that to index into, the vector for whatever it may be. All right, so we've got that. I'm just going to copy that and paste for roughness and AO. And this is going to be roughness source channel, roughness texture channel, and then we're going to have AO texture channel, AO source channel. Okay. So we've got that. Okay, and then emissive texture doesn't need to specify a channel, so we don't have to worry about that. The only other thing that we probably need to put in before we get to lighting information is we probably should be passing these flags in, right? The flags can be used on this side to determine what gets bound, right? But we'll also need it on the shader side to determine what to actually use. So we're actually going to need 2 sets of flags. We're going to need one for the material flags, right, which says what's enabled and what's not, right? And that's for all the various different properties that we have. And we'll be able to extract a lot of information from that. So actually, let's put that in there real quick, right? So flags, right? So we can at least extract that on the other side. And then we're actually going to need one more thing that I hadn't actually thought about until right now. So we don't have a way on the shader side to be able to tell what was bound, right? We can't say, hey, is there actually a texture bound to this or not? Should we use the texture, or should we use, the numeric value that's potentially plugged in? So I think in order to do that, for each one of these where it can vary, I think essentially we'll have a flag that says use texture, and if the use texture flag is set, it'll use the texture, otherwise it'll fall back to using the value. And we only need a handful of those, so a 32-bit int will definitely be enough space to hold on to that. So let's go to material flags. So we're going to set up something kind of like what we have here. So we'll type def and enum. And I'm going to call this actually, this doesn't even need to be on resource types, because this is specifically going to be for this particular shader, and that's it. So actually, that doesn't even need to be there. It can be in here, because it's specific to this actual type of material. So I guess where we put all this other material standard stuff, right? Material standard. Input texture flags. Flag bits. That's really long. Material standard input flag bits. That's better. Oops, that should be an enum, not a struct. Okay. So this is going to be material standard input flag use base color texture. That feels really gross, but that's a really long name. I'm not a huge fan of that. I guess we can get rid of the word material, right? That'll help a little bit. Standard input, though, is kind of weird. You know what? Let's do... We'll just do flag bits. We'll just do it that way, instead of saying input. Thank you for the follow. Welcome. Hope you're doing well. All right, so the next one is going to be normal, or normal texture. I think I've got, this needs to be 2. I'm just going to duplicate this a few times. Let's do metallic texture, roughness texture, AO texture, MRA texture, and emissive texture. All right, so this one will have to be 4, then 8, then 1, then 2, then wait, yeah, I don't think I've done that right, but yeah, I'm increasing that too much every time. That should be, well, wait, no, that is correct, I think. Yeah, okay, I think I got that right. All right. So we have these material standard flag bits, which tell us what textures we're actually using and what textures we're not. So in the in the actual material data itself, actually, we don't even need to store that anywhere. We can calculate it on the fly. So once we do maps here, we'll do, oh, you know what? Oops. Where was that? Let's do also U32, and we're going to call this material standard flags. Okay. I guess we'll call this text flags. All right, so we'll initialize that to 0. And then what we can do is, if we are using this texture, then we can do flag set text flags. The flag we want to use is going to be material standard flag use. Did I really forget base? I did all of them but base, really? No, I had it in there. Why didn't it show up? Base color text. Oh, I put base in here for all of these. That's why these are so long. Should only be in there for the first one. That makes more sense. Okay. So we set that flag, and we're basically just going to repeat this pattern for anywhere where there's a texture in use, right? So this is going to be normal, and then this is going to be the MRA texture. I'm actually just going to paste this a few more times here. Oops. Needs to go there. All right, so MRA. Metallic. Roughness. AO and emissive. Okay, and then down here, once we've done all of that, we're going to have one more of these, where we're going to say the location is going to be oh, did we not add? We'll call it text flags. And this will be text flags, right? So that means we need one more here. So we have flags, and then we have text flags. Texture use flags. Okay. And so we can basically just reverse this operation in the shader and choose whether we sample from the texture or use the value outright. And if we use the value outright, then in cases like this one, we can also utilize the proper source channel and be good to go. Let's see. Yeah, some of these names are kind of long for sure. Let's see. I wonder if Kohi could regenerate the combined texture under the hood. Yes, so we could do that. And in fact, we have a utility to do that in our sort of utilities library. We already have something that will read the files off disk, combine them, and write out a new file. So it wouldn't be a huge leap to take that same logic and roll it into this as well. And in fact, we may provide something that allows us to input actual textures like this and just do that. The reason that I haven't done it so far is because think about a situation where you have different sizes for those maps, right? Like maybe your I don't know, maybe your AO texture is a lower resolution than your metallic texture, for example. Or maybe the opposite is true. Who knows, right? But if those maps are ever different sizes, sampling them separately is no big deal. But when you go to combine them, what do? Do you look through all of them, take the smallest size and stick to that and scale everything down? Or do you take the biggest size and scale the smallest images up to meet that whole image, right? Because if you when you combine them into one image, if the dimensions don't match, you have to decide one way or the other how you're going to do it. Do you scale up the image? And then that gets, and if it's optional, then that gets even a little bit more complicated, right? Because it's like, okay, well, if you scale it, do you scale it using nearest neighbor, or do you scale it linearly, or, on and on and on and on. So there's, yeah, that's one of the reasons I haven't actually just like automated that yet. And that's going to be really interesting when we get to layered or blended materials, how we're going to solve that problem. Because we are only ever guaranteed by the Vulkan spec to have the ability to bind 16 samplers or 16 textures at once. The spec only says you have to have those at a bare minimum, right? So even if most devices out there support a higher number of it, we have to assume that, we need to stick to that lowest common denominator. I know a lot of things will be like, well, we just, adjust on the fly and, do something different for lower end hardware than we do for higher end hardware, but I don't want to have 16 different code paths either, right? I'd like to keep the solution the same. So the way that I'm setting all of this up is we have an upper limit of 16 samplers and 16 textures that we can use. And so when we talk about blended materials, which, each of these materials already has like 7 maps in it, potentially. Obviously you can't have a whole bunch of materials on separate, using all separate textures for all of them, right? You've got to find a way to combine those. And so at that point, we're going to have to investigate some ways to do that. Yeah, mega textures is one of them, right? And mega textures honestly might be how we handled layered materials, right? The only problem with mega textures is there's a few problems with it, right? There are hardware limitations as to how large of a texture you can actually have, first off. And then there's also you have to sort of put padding in between the textures, because when you're sampling it, like especially with like a linear sampler and you're all the way at the edge of a texture, if you're trying to tile that, if you're in a mega texture, you're not going to be able to tile that properly, because you're going to get like sort of the part of the pixel to the right or top, bottom, whatever it is. When you go to sample that edge, you're going to get like bleeding from the next texture over. So then you have to do things like, well, do we just copy the outer pixel all the way around so that we don't have that problem? Or, there's a whole bunch of things that have to be taken into account for that. We could also use layered textures, right? But then layered textures have the same problem with all the layers of that have to be the same size. So yeah, there's definitely some thinking we're gonna have to do about that. Our old school terrain texture, we just flat out said they all have to be the same size, and that's that. And maybe that's what we do, but maybe that's just a limitation that we put in, and that's that. I haven't really decided yet. I'm trying to think of something else that's a little bit more flexible than that, but we'll see where we wind up. Okay. So, textures. Texture. Texture usage flags. Okay. Now the next bit of this gets a little bit interesting again. So what we have here is we've made some assumptions, right? And even in our old system, we made some assumptions that worked, right? But we ultimately need to kind of rethink how we're going to handle this. So we do have something called a lighting system, right? And we can say to that lighting system, I want to register a directional light, I want to register a point light, or whatever it may be. And then we can query that light system saying, hey, give me the current registered directional light. Right now we only support one at a time. Technically we might support more than one at a time at some point. And then we use the directional light that's returned from that to actually set the directional light in the shader, which is ultimately the sun, right? And so we have that, and then we also have like point light count, right? How many point lights do we have? And then we have a maximum in the shader. I think it was 4, or maybe no, it was 10. How many point lights do we actually have, or how many can be taken into account at once? And what this does right now is it literally, we get a point light count, and then we say, give me a list of point lights, fill in this array that we have here with all the point light data, and then we go through that, set the p lights data, and then set the uniform, right, along with the count. And the problem with that is, the lighting system is kind of disconnected from the other systems where, it's not necessarily going to query the scene for any data. It just has like a collection of lights, and like, how does it actually know what lights to grab, right? If we have more lights in the scene than as actually supported in the material, right? How do we handle that? And ultimately, like, we're gonna solve that with a deferred renderer, but we don't have that yet. But we still need to handle it with a forward renderer, because you have to handle transparent objects with that too. So that's a whole other can of worms. So we really need to think about how we want to provide light information to the material system. And lights are going to be treated the same way, no matter whether we're using PBR or we are using Phong as our lighting model, right? It's going to be the same regardless of the type of material that we have, whether it's a standard material, a water material, or a blended material. The number of lights and the types of lights it supports, all that stuff's the same. The underlying shader code's different, but ultimately it's the same, right? So our representation of lights doesn't change based on our lighting model, which is good. So we basically need some way to tell the material system, here are the lights that we want to use for this thing, right? But this thing could, that could vary per what we're drawing, potentially. And so we're essentially going to, eventually we're probably going to have something where if you've got a scene loaded up and you're just drawing stuff close to you, right? You'd probably want to draw with the 10 lights that are closest to you or closest to the object that you're drawing, right? And only lights that actually overlap with that object would you actually use. You wouldn't necessarily use all of them in a scene because that's wasteful. And so we basically need to be able to query the scene and say, okay, scene, for this particular object, which lights interact with it? And then we take that list of lights, and that would have to obviously be clipped by the max. And then we go ahead and we render with those lights. And so it almost to me maybe has to be provided here, right? When we apply the material, right? It almost needs to be passed in instead of us getting it from an external system, right? And then we just go ahead and handle that, right? And the reason that we have it, oh, you know what though? I just realized something. This is all within, this is within the group binding, which is actually wrong. Technically speaking, this should be per draw. But these structures are actually kind of big. Well, they're big once we have multiples of them, right? That's not all going to fit in a push constant. There's no way. Especially 10 of them. I'm going to have to think about this for a little bit. Because technically speaking, if we put it at the material level, then it's got to be all the lights from the scene, and then we index those. Which is a possibility, right? It just makes this unnecessarily large, right? And technically speaking, if we were to do that, these probably would belong at the per frame level. Okay, so I'm going to bat away the ads here for a minute. Should these be per frame? And for the entire scene, then indexed at the per draw level? I think yes. Light count and list of indices into the light array would be per draw. That makes sense. Okay. So, all right. Looking at the time, we're basically out of time, so I'm just basically leaving myself notes here. We made some pretty good progress tonight, I think. I'm pretty happy with that. So this is where I'm going to end for tonight. I do want to point out also, so next Thursday in the United States is Thanksgiving, and I've got family coming into town, so I will not be online next Thursday. It's also possible I might not be on Wednesday. Wednesday is up in the air, next Wednesday. but Thursday, definitely not happening. So just so you guys are aware, I will not be online then. We may or may not do a makeup stream sometime around that. I'm not 100% sure. Depends on what time I have. So the 27th, up in the air. 28th, definitely not happening. Spiro, I appreciate that, buddy. Yeah. Damon, I think that's ultimately the answer, right? To what we're doing here is we need SSBOs, right? But we don't have those yet. So I'd have to put those into place, which is another thing, right? I think that's probably something I'm gonna do after we get the initial I may hack this into place for now, with a to do to come back after we're done with this huge refactor. And fix this issue separately. Thank you for the follow. All right. Yeah, best holiday peepo fat. I love that. Yeah, it's definitely the holiday to get fat, for sure. And I'm okay with it. All right. Eat some pumpkin pie. Definitely will do. Is it only me, or do we have a little bit too much web devs, data scientists, and AI devs? It's not just you. All right, let me pick somebody to raid. See if I can find something loosely related. It's a little challenging sometimes at night because a lot of people aren't on now. But I want to see if I can find something that's loosely related to send you guys over to. Let's see. Well, I don't see any C++ or C dev at the moment. Okay, let's go with Jitspo. He is making a pretty neat looking retro FPS in Godot. And it's actually coming along quite nicely. He's actually done a lot of custom work in it too, to get like BSPs working, like Quake style BSPs working and stuff like that. It's really actually a pretty neat project. So we are going to go ahead and raid Jitspo. And thank you guys so much for joining me. I really appreciate you guys being here. I appreciate the support. And yeah, we'll see you guys maybe next week if I'm able to get on Wednesday. We'll see. Keep an eye out on my Twitter and stuff like that. I'll announce there if I'm going live. But all right, cool. See you guys. Thanks.
Refactoring material system. Yeah, and talking about the Quake 2 VSP format. You could, but the problem is wouldn't know the vertex order in that case. Like, I think you have to follow the edges. Like, if you just copy paste that code, that might get what you need. Oh yeah? Because it's going to give you an edge. So we would start with this edge. So you basically need two edges